Okay, great. It's 5 past, everyone. So let's get started. I hope that everyone had a nice lunch. I guess I should probably start by introducing myself, considering I didn't do it at least out loud earlier today. My name is Julien. I work at EPCC along with Juan. Juan and I do very similar things a lot of the time, actually. So we both spend a fair amount of time working in-depth support for ARCHER2 and I'll just stop the poll real quick because, yeah, thanks, Juan. Yeah, I will be, well, I'm jointly teaching this course with Juan. I will be doing the teaching for this afternoon, and I think tomorrow we will be splitting it. I think I'm doing mostly the morning and Juan's doing mainly the afternoon, but I might be wrong. We'll see tomorrow. So this afternoon, we're going to be focusing on 3 main things. The first thing we're going to be focusing on is the ARCHER2 development environment. So we'll be talking about what software is available on ARCHER2 already, how do you gain access to that software, and how do you, what's the word I'm looking for? How do you use that software? And if that software isn't available, how can you go about compiling the software that you need through the various programming environments? And just a quick show of hands, how many of you have previously used ARCHER1? Just out of interest, if you could put your hands up. Oh, that works. 1 no, 1 yes so far. Okay, cool. So I won't go too much into comparisons with ARCHER1 versus ARCHER2 in that case, because that won't be too interesting. Yeah, so other than that, we'll be talking about that. Then I'll be talking about the scheduler that we use on ARCHER2, which is the Slurm Scheduler. I'll be talking a bit about how to use Slurm, how to submit a Slurm job, the various ways in which you can run something on the compute nodes using Slurm. And then at the end, we'll finish off with a small exercise to get you to think about performance on ARCHER2 and how to measure performance on ARCHER2. So that's the end for this afternoon. But for the next hour to hour and a quarter, we'll be talking, as I said, about the development environment on ARCHER2. So actually, I'm going to share my full screen. Let me check. Yeah, I'm not. Yep. I'll share my full screen instead of just this. Moment. In case, well, just to repeat it, I'm sure we have definitely told you this before, but please be aware that this session is being recorded and that the chat is also being recorded. So any questions that you write in chat, we might take the question and put them on the final video of this, but we won't be keeping your name to make sure that it's anonymous, etc., etc. But yeah. So with that, let's talk a bit about modules on ARCHER2. So ARCHER2, I'm logged into my account. ARCHER2 has a number of modules available. And what are modules? Well, modules are ways of keeping are ways for the in-depth support team to keep centrally installed versions of certain software available for any user to use. There are a huge number of modules available on ARCHER2, and you can find all of the modules on ARCHER2 by typing module Avail, and that'll show you all of the modules. The first few that come up, you'll notice are all have the CSE somewhere. That's to show that they've been created by the ARCHER2 CSE team, so the team that Juan and I are both a part of.
Are you sharing your screen?
I was hoping so.
I mean, it happens to me this morning that I have to do this twice in order to share the screen. We cannot see it.
Okay.
Okay, yeah, now.
There we go. Can you see it now? Thank you. Cool. So what was I saying? Well, I was saying if you want to see the modules available on ARCHER2, you can type module avail, and it shows you a very large list. And when I say very large list, it's I think about 100 lines, maybe a bit less than 100. Oh, more than 100 lines. Of all of the available modules on ARCHER2. The ones at the very top are the Csc modules, the ones that have been created by the ARCHER2 support team. And you have things that you might recognize, like TensorFlow, Torch. For memory, Torch is for machine learning. There's other ones like small useful ones like GNU-plot for plotting. So we've got like different environments, we've got different utilities thing. And then finally, we've got some libraries, things like Parmetis, like PetSC. And then also we've got the applications that are centrally installed and available on ARCHER2 and kept and updated by the ARCHER2 support team. Those include codes like CASTEP, CP2K, Gromacs, LAMPS, NAMD, OpenFOAM, VASP, Quantum Espresso, that sort of thing. And then once you've got through all of these modules that have been installed by the Csc team, you come to the modules that are made available by Cray. So created by and maintained by Cray. Things like performance tools, we'll be using some of those tomorrow. Looking at profiling. There's the huge pages for if you need larger pages. I've never actually had to use them. There's the programming environments. We'll talk about those in a bit. And then there's other things like the Cray FFTW library, the HDF5 parallel library, and the HDF5 library here. libsci, mpitch, etc., etc., etc. And yeah, so there's a ton of modules available on ARCHER2. Now, when you log into ARCHER2 for the first time, you'll have a certain number of modules already loaded up. You need a certain number of modules there in order to be able to A, see some of the modules available, but also B, just make the system work well. You can check at any time which modules you have currently loaded by doing module list. And that shows you the 15 modules that you should have loaded at the start. If you've just logged into ARCHER2 and if you've not loaded any modules, that's what you should see at this point. So the modules that you have loaded when you first log in is the programming environment, the Cray programming environment, the Clang CCE compilers, the Cray programming environment. These are to define which version of mpitch you're using. I believe the Cray Network OFI also defines that. libfabric we'll talk about a bit more in a sec. There's some Perf Tools, and by default we now have the Cray libsci loaded, and that has things like BLAS and LAPACK associated with it. And then the last three modules you'll see are modules which gives you access to the CSC setup environment, the EPCC module loader, and the CSC profile, so that you can see all of the modules that have been generated by the ARCHER2 in-depth support team. So that's how you see what modules are loaded when you log in, and that's how you can see all of the modules that are available. Now, on certain systems, you are able to, and please don't do what I'm about to do, but on certain systems, if you're unhappy with the modules you have loaded at the moment, you can sometimes run a module purge command. That gets rid of every module currently loaded. If you do this on ARCHER2, you will get you will run into a very interesting problem. I'll do it for demonstration's sake. The problem being that now if I run module list, I don't have any modules currently loaded because I've just purged them. But if I run module avail, I can only see the Cray modules, none of the Csc modules, so none of the libraries like Gromacs, or none of the applications like Gromacs, like CP2K, like VASP, etc., etc. I can't see those. I only see the Cray environment. That's just the quirk of ARCHER2, and therefore, if you were wanting to use any of these other modules that I mentioned, or any of the modules that have been installed by the in-depth support team, running purge makes it very difficult to do so. And if that happens, your best bet is going to be to exit and then to log back in. And remember your password. Oh yeah, first go. And now if I run module list, I'm back to the 15 that I had before. So we've had a look at what software is available. I'm happy to go into more details, and if you have any questions about what is available, please post it in chat, and Juan and I will be more than happy to let you know whether or not it's there or not. But let's have another quick look at another way that you can check whether a software is available. Let's say you're interested in whether, I don't know, let's say Parmetis, for instance. I don't know why Parmetis. You can search module Avail lets you specify what you're looking for. So I said there was Gromacs before. If I do module Avail Gromacs, it will show me all of the Gromacs modules that are currently available on ARCHER2. They're not loaded up for me, so if I do module list, you'll see it's not part of the list there, but you'll see that module Avail shows me that there are two versions of Gromacs available, 2020.3 and 2020.4. The module Avail with name does accept wildcards, so I can do asterisk part, actually I'll just do metis, like that, and if there is a module with the letters METIS all combined anywhere within the name, it should come up. And there are indeed two. There's metis and there's parmetis. So that's a nice quick way of looking for things if you're not wanting to go through the 110 lines worth of three-columned names of modules, 3 per column or whatever it was. It can help you find things a lot more quickly. So that's how you can see what's available, what's there. How do you check which module is which, however? So I mentioned, for instance, the Crelipsi module. How do you find out more about this? So there's a couple of those, and you'll see that there's two of them. One of them has default written next to it, and one of them doesn't. So how can I find out the difference between these two? Well, the first thing I can do is I can learn more about the module by typing module help Crelipsi, and then I get a help folder. And most modules will have one of those which have more or less information in them. So this one tells me that this is Crelipsi, it's version 20.10.1.2. I can tell it's 2 because it's there. Released in October 2020. And then it tells me, what does it tell me? Well, it tells me that it provides scientific libraries for the Cray slingshot system, and it contains things like LAPACK, like ScalaPack, QDWH, and lots of other information about this. It then tells you if you want to run it, you need a certain number of things. So you need at least Cray MPitch 8.0.7, Cray P 2.6.4. It gives you all of the dependencies. This is not all module files will go into this much detail. This is a very well-kept module file. But yeah, you get a lot of information about the file, including sometimes, at least for the Cray modules, you often get a link to where you can documentations learn more about it. And if you were to then check that documentation, you could do libsci to get even more information about Cray libsci and how to use it. I'm not going to go too much into this because this is the course about Cray libsci. So that's one way of looking into it. And this module help works for any module. So say one of the ones that's centrally installed has a much smaller help, but it still gives you the information you need. So Gromacs module, the Gromacs module will load up Gromacs version 2020.3. Once it's loaded, you can have single and double precision MPI executables with GMX MPI and GMX MPI _D for if you want double precision. So that's finding more about modules. You can So then the next question becomes, how do you load how do you get access to these modules? Because at the moment, the Gromacs module said that if I did gmx MPI, I should have something, but at the moment I'm finding nothing. To load a module, you run module load and the module you're interested in. So in this case, Gromacs. And now if I try to run gmx MPI, it's going to be unhappy because I'm going to try to run an MPI thing, but I'm no longer getting a command not found. I'm getting a there's an error because you're trying to run an MPI job on the head node, on one of the login nodes. The other thing to bear in mind is if I do module list, you'll see that now instead of the starting 15 modules that I have a 16th module, which is Gromacs, and it specifies it's Gromacs 2020.3, and then in brackets, default. Why does it say default? Well, the command that I typed was module load Gromacs. And so when you don't specify the version you want, when you don't specify anything after the front slash, and indeed if you don't use a front slash, it will always assume that you're going for the module of that name that has default after it. If I wanted the other one instead, I should have specified 2020.4 plus plumed. Let's say that I did want 2020.4 plus plumed and had accidentally loaded 2020.3. I could not just do this. So just trying to load that shouldn't work. I would get an error message, and I do get an error message, because it's telling me this module cannot be loaded because there is a conflict. And then it gives me a hint. Maybe you want to try module unload Gromacs first. So, well, what's happening, I'm sure you've all guessed. If I run module list, I've already got a Gromacs module loaded, and what the module system is telling me is, hang on, you can't have Gromacs loaded twice. You can only have one version loaded at any one time. And then it's even more helpful than that, and it tells me exactly how I can fix this, which is namely by running module unload Gromacs. And if I now module list, Gromacs is unloaded. I can unload any module that I have loaded up by running module unload. I mean, I could show you by, I don't know, I can unload Bolt, for instance. So Bolt is right here at number 12. I can unload Bolt. It does not seem to be, nope, I can't unload Bolt because, oh, well, I'll unload Krelipsi, actually, that's a good one. There we go, and now if I run module, so Krelipsi was, where was it? Number 11. And now if I look, I've only got 14 modules available, and number 11 has become Bolt. That's because I've unloaded Krelipsi. So that's one way that you can unload the modules. And going back to our previous example, now that my module, Gromacs module is unloaded, I can module load Gromacs 2020.4. One thing that you're not going to be able to see as much because I'm doing this online is autocomplete works in this. So here I've typed 2020.4. I can then press tab and it'll add the plus plumed for me. So tab, there's the plus plumed. And I press enter and it's happily loaded that because there's no longer a conflict. And if I run module list, I have Gromacs back happily available. So that's that. The next thing is, let's say that I've now realized I actually wanted 2020.3 instead of 2020.4. Another way to do this in one command rather than two is you can use a module swap command. You run module switch or swap. I prefer swap for some reason, though it goes to switch. Gromacs for Gromacs 2020.3. And that module switch command will unload the Gromacs 2020.4 module and then load up the 2020.3 module. So it's a way of saving time by having one command do two things. Cool. So I'll talk a bit about licensed software in a sec. Just seeing, where we are. I've talked about module help. I have talked about loading and switching modules. Cool. So let's talk really briefly about about licensed software. There we go. If I do module Avail again, and I'm specifically interested in the CSE apps, there we go. So I'm specifically interested in this section and under here. There are, I don't know how many of you are well versed in what all of these modules mean, but some of these modules are licensed. So for instance, VASP is a licensed software. We have an agreement with the VASP developers, whereby we can maintain a central copy, central version of VASP on ARCHER2, and have it installed and available to our users. But anyone who wants to use VASP must first have their licenses checked by the VASP developers. And I'll talk a bit about how you can do that. There are a couple of other licensed softwares available. For instance, Castep, I think Crystal is another one that we do. And then there's one more that we do somewhere. Cool. So what does that mean? Well, before explaining that, actually, I'll explain something else, which is the module show command. The module show command shows you all of the environments that are set when you so it shows you all of the environments that are changed when you load up a module. So for instance, when a module show Gromacs, it shows me that the Gromacs 2020.3 is in conflict with any other module called Gromacs, and what it does is it adds this to my path. Now, why does it add this to my path? Well, quite simply, I'm sure you'll have guessed, it's because that is the place where the Gromacs executables are. And indeed, here you can see the GMX MPI, you can see the GMX MPI _D. There's a serial version of Gromacs as well, which means that I could run any of these executables. And if I do serial, because I'm on a head node and I can only run serials, it runs, and that command was meaningless, but it runs and I'm able to run it. So that's one of the nice things about module show. And one thing to note is if I were to, I don't know, for instance, if I were to ls into that directory, I can see all of those executables. I have permissions to see all of those executables. Part of the reason for that is because Gromacs is an open source software, which means that anyone can download and share their copy of the software with anyone else. That's fine, provided that you're not profiting from it. The Gromacs developers are perfectly happy for you to do this. This is not true for programs such as VASP or Castep. And if I were to try a similar thing for, let's say, VASP, I can module load VASP. There's two versions of VASP. So let's go with, I don't know, 5. There we go, and I do module list. I now have VASP 5 available. And if I were to try to see what the executables associated with this were using the same module show command as before, let's see, added to my path is this. So /work/yo7/shared /VASP5, etc., 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 is the directory in which the VASP5 executables are kept. If I try to run ls into that directory to see what the executables I can now use are, I get a permission denied. The reason for this is quite simply because I do not have the permission to look into the VASP5 directory because I am not approved as a license holder on ARCHER2. What does that mean? It means my license has not been verified on ARCHER2, which means that I cannot I cannot access the executable until I've applied license. So now I will apologize for the tunnel, but I'm going to stop sharing there. Yeah, quickly stop sharing there and then share just a bit of my screen to show you how do you get access to licensed software for ARCHER2. So to do this, you'll need to log into Safe. I will need to get my password. Checking, yep, you cannot see what I'm doing, that's good. Where was I? There we go. So you need to log into Safe, and then from Safe, you need to go on Login Accounts, choose your login account. I have way too many login accounts, and trust me, Juan has more than me. And when you're on your login account page, which tells you, well, you know, this is your username, TA022JS. This is for account TA022. It has 1,000 computer units in this much space. You keep going. This is my SSH public key. Then you have all of these buttons that let you do a number of things, like adding new SSH keys if you want, deleting SSH keys if you're unhappy, confirming the terms. I think I've already done this. Everyone has to do this upon creating an account now. Asking for your password to be reset, seeing what your temporary password is, etc., etc., etc. One of these buttons is request access to package. And if I click on there, I get a drop-down menu that shows me, well, I can request access to packages like Step, like VASP, and a couple of other packages. Crystal I mentioned before, but there's a couple of other packages, all of which are licensed packages that are mostly available on ARCHER2 already. I know that ChemShell isn't quite ready yet. The MetOffice unified model is available. Crystal, I think, is just about available, and CASTEP, VASP are available, and I'm not too sure about OneTep. So if I were wanting to get access to VASP 5 on ARCHER2, I would click on the VASP 5 license. I would click select. Here in access detail, it asks you, it tells you at the very top, if you want access to this, we need the following details. Please supply your VASP 5 code and the name of the research group leader, so your PI, for whom the license is registered. So in this case, I personally do not have a VASP 5 license, so I'm going to please disregard. So I'm putting a word to the ARCHER2 help desk operator to know that they can just kill this and not worry about it. And then once I've put in the details that are required, I just click submit, and that query will have been sent. And if I look at, I'm not going to look at current queries actually, because that might show other things that I'd rather not show. Yeah, so that query has been sent, and the ARCHER2 team will get in touch with the VASP developers to make sure that your license is appropriate and that you gave the right license number, the right information. And if everything is okay, then they will get back to you and add you to the VASP 5 user package, meaning that you'll have access to the VASP 5 executables, which I currently cannot see and will not be able to see because I've not provided the correct details. So that's how you do licensed software and get access to licensed software. I realize I've been talking fast and saying a lot of things, so at this point I'll take a second to check what questions you may have. And please feel free to ask, what modules are available. That's also something we're more than happy to answer. And as there are no questions, I guess I'll keep going a bit. Please also let me know on Collaborate, if you click on your portrait right under the screen that's displayed, you can change things like saying that you're away. If you're away, you can say whether you're happy, surprised, sad, or confused. You can also put faster or slower, and that'll help me to gauge whether you think I'm going too fast or too slowly. If you say faster, I'll assume you want me to go faster. If you say slower, I'll assume you want me to go more slowly. And if I don't see anything, I'll just assume that it's all good. Cool. So we've done loading and switching modules. Now we get to switching between compiler environments. So on ARCHER2, there are 3 compilers. There is the Cray compiler environment, the GNU compiler environment, and the AOCC compiler environment. Sorry about that. What these means? Well, each compiler environment gives you access to certain compilers. So one of the most used compilers is GNU, the GNU compilers, which have libraries like GCC, but then there's also the Cray compiler environment, which offers things like Cray is nowadays is a version of Clang if you're wanting to compile in C, and is still a Cray version of Fortran if you're wanting to compile in Fortran. And then there's also the AMD Optimizing Compilers under the AOCC banner. Let me quickly share my other screen. Check that that works. Yeah, that seems to work. If I go like that, it still stays. Sorry, this is not going to work, and I apologize for the tunnel. This is taking, sorry about this, this is taking a small sec to, there we go. These different compiling environments do just mainly let you compile using different compilers that might have different optimization flags, compilers that might perform slightly better in certain situations. So sometimes you might want to use one of these various different compilers. One thing to note for anyone who was an ARCHER2 user, sorry, I heard a question. I'll just try to. Do the 3 environments have the same ABI? Can you link objects from different ones? They all have the same absolute path, yes, so you should be able to link objects from different ones. Whether you'll get things you like out of that or that work well out of that is a very different question. I would say probably, but do so at your own risk. One thing to note for anyone who's an ARCHER2 user or an ARCHER1 user, ARCHER1 used to have Intel compilers. On ARCHER2, there is no Intel compiler environment. We've installed some of the Intel libraries, so like Juan was saying, we've got the MKL libraries available, but we do not have an Intel programming environment, mainly because we're not using Intel processors. So if I run module list, you'll see that I've got 17 modules loaded, including Gromacs and VASP as my last 2. To change programming in environments on ARCHER2 is a bit strange and very different from the ARCHER1 method of doing it. Whereas in ARCHER1, you could do a module switch PRG, ENV, in this case it would be Cray, PRG, env, let's say GNU, this command does not work on ARCHER2. And indeed, just to show you, it just doesn't work. Instead, you need to do a module restore command. And what module restore does is every one of the three programming environments has a set number of modules that that the system thinks should be loaded with that programming environment. And what a module restore does is it will unload all of your modules and reload just the ones necessary for that programming environment. So anything that's superfluous, anything that you might have added in the meantime, will go away. Just to emphasize this, so there's three available. There's AOCC, Cray, and GNU. I'm going to go for GNU. It then tells me everything that it does. So it tells me it's unloaded all of these modules, still unloading modules, still unloading modules. And now it starts loading things like CPE GNU, GCC for the GNU compiler environments, CrayPE, libfabric, etc., etc., etc. And after that, it's finished loading the new module environment. And if I run module list, you will notice that I am down to 14 total modules loaded compared to the 17 I had loaded before. And there's a number of modules that are different. So instead of CPE, Cray, and CCE, for instance, I now have CPE GNU, so Programming Environment GNU, and GCC for the GCC compilers. But other modules are also no longer there. So things like Gromacs and VASP are no longer there because they've been unloaded when you restore your module. This has certain benefits and downsides. The obvious downside is that if you restore a module, if you restore to a different programming environment, you will need to load up any module that you had loaded before that again, if you're wanting to still use them. The one major upside is it acts as a very nice refresh. You know that if you're not sure which bits aren't working, you can just restore a module to get back to this base state from which you can carry on your work. For debugging, it can be super useful. So that's the upside and downside of the module restore command. Yes. One last thing that I wanted to mention is, so you'll have noticed that when you restore to a module, let's go to AOCC just because it's got a funny name. There's a lot of text that gets written. You can always, you can use the -S for silent flag to make the module restore happen without any text available, so without any text to screen. So if I do a module list right now, you'll see that I am in the CPE AOCC, and I've got the AOCC compilers loaded at the moment. But if I run module restore -S programming environment GNU, and then run module list, I'm now in the GNU programming environment with the GCC compilers loaded, but I've gone to there without having all of the text output to screen, which can be a nice, it's a neat little trick if you're at all bothered by the amount of text printed to screen. I tend to usually use the -S command just to make things look a bit neater, but do as you will. Right. So swapping between compiler versions. This is very much similar to a normal module swap. So we're in the GCC, we're in the GNU compiler, the GNU programming environment with GCC loaded. The GCC module is like any other module, which means I can run a module avail GCC, and it'll tell me that there are 3 available versions of GCC currently available. There's 8.1, 9.3, and 10.1. 10.1, the newest one, is the default version. Like with any other module, I can run a, if I can type, I can run a module switch command, let's say I want to use 8.1 instead. And there, bam, I've got GCC, where will it be? There it is, right at the end of the 14. GCC 8.1 is now loaded. So the compilers are like any other module. I can swap them. I've never tried, but I doubt. Yeah, so I've got other compilers are available like AOCC. I'm not sure what would happen if I load up AOCC in the GNU compiler programming environment. I've never tried doing that. Maybe interesting things would happen, but I guess there's nothing to stop me doing it. Let's try it, right? Cool. And just get a bit ahead of myself. Cool. Yeah, so it seems to be able to load fine, and I'm not too sure how. That would affect any compilations that I want to do because I've never played around with that, admittedly. Maybe Juan knows, I don't know. And I'm just gonna quickly go back to the base Cray environment and carry on. So that's how you can change the version of the compilers that you're using. And how you can change between various programming environments as well. Why would you be interested in doing that? There are some software which are really built more for being compiled with certain compilers. Quite a lot of scientific software uses, I've found, mainly GNU or Intel. But I'm sure there's others that are optimized for Cray, for instance. Definitely there's a lot that's optimized for Cray compilers. And there's probably a couple that are also optimized for AMD. Not all versions are guaranteed to work. For each Cray programming environment, so each Cray programming environment release is released as a coherent set of software packages that is guaranteed to work together as a whole. So this is kind of re-emphasizing the point that I made of, yes, you can pick and choose your various modules, and yes, you can have the AOCC compilers loaded up in your GNU programming environment, and maybe that'll work, but there's also a large probability that it will not work. So do be aware that combining items, even items from two different programming environment releases that use the same compilers, so even using an older, for instance, version of the GNU compilers with a newer version of the programming environments, might result in some incompatibility issues. And now the final thing I wanted to talk about in this section is the compiler wrappers. So, and actually for this, I'm trying to think what the best way of doing this is. Oh, I can do it this way. Cool. So what I'm doing is I'm stealing a quick Hello World in Fortran program from another account, and I am going to, because I'll be trying to run this as well at some point, I'm going to run this from work. Here we go. So this is a Hello World in Fortran program. I'm also going to copy it to the Etherpad. If anyone is interested in doing this as I do it, you're more than welcome to. Oh dear, it has not. It's not done any of the spaces because it's a silly. Go.
If you want to copy the file in ARCHER directory,
Oh
maybe.
yeah, that's an even better idea. Yeah. So I'll copy the file hello.f90 to /work/tao22/shared. Good suggestion. So anyone can find the hello.f90 file there. And I will put the link in the chat. Apologies for the tunnel, which is about to come up. There you go. Cool. So what is this? Well, this is a Hello World program in. Yeah, cool, awesome. Thanks, Juan. This is a Hello World program in Fortran. What's it doing? It's not doing very much, frankly. It's calling MPI init, and then every single core that this is being run on will get a number from 0 to the number of cores that are being used, as well as know the total number of cores used in the system. And then each core is going to write hello world from processor, its number, out of the total number used, processors, and that's it. Tiny, small, parallel hello world program. Module list, which programming environment am I in? Let's swap to GNU because I like GNU. -s PRG env GNU. There we go. And just sanity check, I'm in GNU. So if I wanted to compile this, and it was a serial chord, the way I'd do this is just gfortran hello.f90. Unfortunately, because it's not a serial code, if I do that, I get a fatal error because it does not know what MPI is. Makes sense. Now, on my local system, if I wanted to compile this, I'd be running something like MPI, I think it's MPI F90, and then the thing. However, MPI F90 is not a known command. On ARCHER2, the way things are done is to facilitate and to help anyone who's trying to compile things in parallel, as in compile parallel programs. We use compiler wrappers, and these compiler wrappers are contain a hell of a lot of information, actually, but the important thing is that they contain all of the compiler information that you need to compile in parallel. So there's 3 compiler wrappers, one for Fortran, one for C, and one for C++. The Fortran one is FTN, the C is lowercase cc, and the C++ is uppercase cc. So if I were to run ftn hello world, hello.f90, I would be using the compiler wrappers to compile my program. And look at that, it's compiled, and I now have an executable called a.out. Let's remove a.out and actually make that a bit neater if I wanted to. And now I have an executable called uppercase hello.x. That is a, what's the word I'm looking for? That is an executable, and it can be executed. However, because it's a parallel executable, if I run it on a single processor, it's not going to be happy because of MPI reasons, and I can't run it on more than one processor on the login node. So I would need to launch it on the compute node, which we'll do after a break, which we're about to have. So that's how the compiler wrappers work. Now, there's a lot of really interesting things about the compiler wrappers, which are that whenever you add certain modules like the cray libsci module, or there's other modules like the cray FFT libraries and things like that, the cray netcdf libraries. Whenever you add those modules, most of the modules here in the programming environment module files, things like libsci, things like FFTW, things like that, the compiler wrappers will automatically be updated so that the path to the appropriate libraries that you might want to link to in your programs are are part of the compiler wrappers. And at the end of the day, you can compile to things like the crylibsci module without needing to have an explicit path to your library. So for instance, you can get to crylibsci without having to, in your code at any point, use the -l lib_sci or -l lib_blas or things like that. So they can really help your program. They can really help make your life easier if you know how to use them. And yeah, one thing to note is that there is an awful lot of information about compiling in the ARCHER2 documentations under the best practice guide. There it is, application development environment. It tells you an awful lot of information about how to use how to get the most out of your compiler flags. I will put a link to this page in the course. Apologies for the tunnel again. But yeah, there's loads of information about this in the ARCHER2 documentations, and indeed a lot of other information about various things. We try to keep them interesting and good. But do please let us know if there's anything you feel we could do better to make them better. So those are the compiler wrappers. And one last thing I forgot to mention is, so I've shown you how to use the compiler wrappers on a parallel program, one that uses MPI in this case. They do work for serial programs as well. So it's not just parallel code for which you can use the compiler wrappers. However, you do also have the option in serial of just using the basic G Fortran. Right, so with that, I think, dynamic linking, I completely forgot about that bit. Every program that you make on ARCHER2, so ARCHER2 currently only supports dynamic linking. You can't really do static linking, which can be a bit of an issue for a lot of programs. So as well as linking dynamically, all of the HPE Cray software libraries are added to the executable run path. So at any time you can echo run path, run path or underscore path. So this was not particularly interesting, probably because I don't have any interesting modules loaded. What would be a fun one to load? I don't know. I can't think of any off the top of my head. But yeah, so anything interesting would be added to the run path module. So sometimes you might need to add things to run path. But the really cool thing is that if you, let's take the lamps module, for instance, so I think that works quite well. If I were to load the lamps module and module show lamps, maybe ls would help. There we go. So this is the lamps executable, and you can check and see which what are the dynamically linked libraries by running, I think it's LLD, though it might be LDD. I always get it wrong. There we go, LDD gives you a list of all of the dynamically linked libraries for this particular piece of software. And you'll see, looking at that one, so lib standard C++, for instance, links to /opt/gcc/ everything else, and it tells you where all of those libraries are linked, so including the FFTW library, etc., 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 etc. Now let's keep an eye on this one, the libgfortran. One of the really cool things about the Cray programming environments is I'm going to cheat a little here, and I'm going to copy that executable to here. Hopefully that doesn't take too long. So if I run ldd-lnp, this is the same executable with all of the same things. It's just that it's copied to here, which means that when I'm about to restore the module, it won't disappear. If I run a module restore, minus s to, I don't know, let's say prg and cray, we'll be looking at this one. At the moment, the libg-fortran library is pointing to /opt/gcc. If I run a module restore and then run ldd on my lamps directory, the libg-fortran is now pointing at /opt/cray/ is it pointing at the same library? It shouldn't be. I might have gotten this wrong. But essentially what I'm trying to show and doing quite badly at is all of these libraries, when you swap programming environments, point to the relevant library in the new programming environment that you're in. So that can make it a lot nicer and a lot more easy to keep your things working in different programming environments, which is really cool. Right, so with that, that almost concludes our course. The last thing that I wanted to mention is that if you ever have any problems with software, definitely any of the centrally installed software, please do first look in the ARCHER2 documentation. For every single piece of centrally installed software, if you go in the software libraries, you'll find information about any of the libraries. And if you go into the research software, you'll find information about all of the research software that's available on ARCHER2, including things like VASP, which we played around with a fair bit here. It gives you information about what it is. So this is a computer program for atomic scale materials modeling. It tells you a brief introduction about what it does. It gives you useful links to the VASP page for if you want to go to that program's page. And then there's information about how to use it. It mentions only available for VASP license people with VASP licenses. It tells you how to run it, the executables that you have access to. And then there's always as well an example Slurm script. We'll see a lot more of these after the break. But there's an example Slurm script to help you see how a script should look for when you're running it on ARCHER2. And then lastly, there is always a link to the build instructions that were used. That links changed recently, which means that we should really update those. Yeah, so there's, when this works, there's a link to the ARCHER2 GitHub page where we have a list of the build instructions for all of the software that we've compiled. If the page doesn't answer your question, if you don't find the answer to your question on the ARCHER2 documentations, then please do send your emails in to the ARCHER2 service desk. You can email support@archer2.ac.uk. And you can let us know your query, and someone from the support team will be in touch to help you either compile your program, get your program running, or anything like that. So with that, I'll finish with the key points. The key points for here were that the development environment is controlled through modules. There are 3 compilers that are currently supported on ARCHER2. There's the GCC, the AMD, and the Cray compilers. Whenever you want to access your compilers through the compiler wrappers, you need to use ftn, lowercase cc, or uppercase cc to get Fortran, C, or C++ respectively. And finally, the Csc service can help with any software development issues. Now, I think the next thing is a 15-minute break, but we're also meant to be back at 50:30. So could I get a quick show of hands? Would you rather have 15 minutes and we come back at 20 past, if that's, or 30 minutes and we come back at 2:30? If you'd like 15 minutes and we come back at 20 past, please put your hands up now. Oops. 15 minutes, and 1 hands up. And just in case to make sure, if you'd rather have 25 minutes and we come back at past, please put your hands up. No, okay, yeah, we're definitely core 8 on 15 minutes. So in that case, let's reconvene at 20 past 2. Okay, well, I hope that everybody had a good break. And with that, let's start the penultimate session for today, which is going to be about the ARCHER2 scheduler, which is Slurm. So in this session, we'll be talking about how to write a job submission script, how to control jobs, how to find out what resources are available, and just generally how to use Slurm. So ARCHER2 uses the Slurm job submissions system, or scheduler, to manage resources that are available to users. There's a number of Slurm commands that we'll be playing around with. Let me clear that. There's a number of Slurm commands that we'll be playing around with. The first of which I'll be talking about is the sinfo command. So all Slurm commands start with S, and then the actual name of the command. So sinfo will give you information about what the queue. Actually, I'm going to full screen this about what the queue currently looks like. So if I type sinfo, what do I get? I get an output which has a couple six columns. The first one is the partition. You'll notice that all of the machines are on the partition standard. So you've got the first entry is standard, second is standard, standard. The reason for this is that Slurm was originally built with the idea of giving you the option of having a cluster that's made up entirely of nodes of a similar type or nodes of different types. So you can have older nodes with newer nodes, or you can have, as is the case in ARCHER2, all of the same nodes. In the case where you've got older nodes and newer nodes, for both communication and computational power reasons, it can sometimes be advantageous to keep the older nodes separate from the newer nodes in separate partitions. So in that case, you might want to, you might have a partition for new nodes, which is slightly more expensive to use, and a partition for old nodes, which is slightly less expensive to use. Because all nodes are the same on ARCHER2, especially at the moment, we've got all of our nodes on partition standard. Then availability, that tells you are the node, as far as the system is concerned, should the nodes in this subsection be up or not? And as far as the system is concerned, they should all be up. That doesn't mean that they necessarily are all up. It just means that they should be. Time limit tells you the length that the longest job you can submit to this part is. And the way that this is written is you get days hyphen hours, minutes, seconds. So you can see that for all of the various parts of this output, you have what's the word I'm looking for? You are able to run jobs that are up to 1 day, 0 hours, 0 minutes, 0 seconds. So they can run for exactly 24 hours maximum. Then the next bit tells you how many nodes are in this part of the system. And you'll notice the first part has 18 nodes, the second has 14, the third has 10, and the fourth has 980. And the final bit tells you the state of the nodes for this particular bit. And you'll notice as well here that the nodes are separated by their systems, meaning that we've got 4 different rows of 6 columns. And the difference between the 4 rows is that, well, row 1 has drained with an asterisk, which means it's probably nodes that have a problem with them, and we're not quite sure what they are yet. Or at least Slurm isn't quite sure what that problem is, though our systems team might very well know. There is drain without an asterisk. Those are nodes that have been drained and are either powered off or being worked on at the moment by our systems team, but Slurm has been informed about this. There are reserved nodes. Reserved nodes are nodes that are part of a reservation, which means that do not currently have anything running on them. So someone is currently paying some computational time or some time in order to make sure that there are these 10 nodes available for users as and when they need them. And then finally, you'll notice that there are 980 nodes which are currently in allocated state. So two quick things to say. The first one is Juan mentioned that there's about 1,000 nodes on ARCHER2, and if you do the maths, that gets you to around 1,000. There should be 1,024, but there's a couple that have problems, which is why it doesn't add up to quite 1,024. Though it's not too far off today, I have to say. 1,022. We've only got 2 unaccounted for. That's quite nice. The other thing to note is one of the states that you can have is idle. And idle nodes, maybe if I sinfo again, you'll see that there's now some idle nodes here. Idle nodes are nodes that don't currently have any jobs running on them. Those are, and they're either idle because there's no jobs currently queued to run for that node, or they might be idle because they're waiting for for more nodes to become free so that a larger job can run. But as you can see from just this brief overview, at the moment, the ARCHER2 system is super busy, and that's been the case for the last month or so, frankly. So that's the sinfo command, and that really tells you a lot about the current state of the system. So we've talked about partition available, yep. The states that the nodes can be in, so idle we've talked about, alloc we talked about, it's allocated. Draining we've talked about as well. Down just means that the node is currently unavailable. Failed means that there's the node is in fail state. And maintenance is for if a node is in maintenance. Now, very rarely are there more than, when nodes are in maintenance, usually the entire system is in that state, or we have it set up in such a way that as soon as a job is finished on a number of nodes, those nodes go into maintenance. There's very rarely a case on ARCHER2 where there's nodes in maintenance and other nodes idle. The reason for this is we usually put the system into maintenance before we do some maintenance on it and turn off, usually turn off the system or at least restrict access to the compute nodes for users. So if you see that sinfo has a number of nodes in maintenance and that number is running up, it probably means that the system's about to go in maintenance. We usually do send an email about this, so if you hadn't heard about it, do check your spam folders in case you missed an email from the ARCHER2 team telling you that ARCHER2 is going down. If you wanted to, you could run the sinfo minus uppercase n minus l command, and that would give you a node by node status for each individual node. The uppercase minus n means give me the sinfo per node, and the minus l gives you says give me the long version of it. Don't cut it down to just 6 columns. I want the full thing. You don't need to do this if you don't want to, because it's a mess and it's super long. But yeah, there you go. You can see all of the nodes on ARCHER2 with all of their names, and it's telling you what they are at the moment. So for instance, we can find out that node 1933 is currently allocated. It's got 2 processors, each of which has 64 cores, each of which has 2 logical cores, multi-threading essentially. It's part of the standard partition. That's the amount of memory, so it's got 256,000 kilobytes. So is it 1,000 kilo? I think it is 1,000 kilobytes. It might be 1,000 megabytes. I can never remember. Sorry for scrolling. Actually, I can do that differently. There we go. Memory. Yeah, I think they've got 256. I can't remember. They might have 1,000 megs rather than 1,000 kilobytes. It might be gigs. Temporary disk space 0. Weight is 1. And yeah, other information like that. There we go. So now it's possible as well, if you're interested in a very specific compute node, you can find out some specific information about it by using this command. This is not so useful unless you've got a job that's taking forever and you want to check that the nodes associated with that job are working, which rarely happens so far. Let's do 1066 because I like 1066. There you go. Using this command will tell you the host name of the node, the number of CPUs it has, and the memory it has. That's because you've specified that you're interested in the node name, the number of CPUs, and the amount of memory. The number of CPUs, you'll notice that it's got CPUs as 256, which seems a bit weird, considering that Juan earlier today told you that each Archer node has two 64-core processors. The reason for this is that Slurm will count logical cores as separate cores in this CPU count, whereas in most cases, you're more interested in running, or it's advantageous to run on physical cores. So each ARCHER2 core is multi-threaded and can act as two logical cores, but still it's usually better not to use multi-threading because you get better performance for it. But we'll talk a bit more about that actually in a bit, and tomorrow. So now the next one is a quick exercise for you to do. So you're able to explore a given compute node and have a look at what it does and things like that. Another thing that you can do is search nodes by their states. Are you able to find a way to see all of the free nodes on the system? So if you all want, I'll give you 5 minutes to quickly see if you're able to find a way of finding all of the free nodes on the system. Please write done in the chat when you're done. So this might be a bit of a difficult task to do at the moment, given that there's not very many nodes that are currently idle. So maybe it's easier to do the ones that are currently reserved. If you wanted to find out the list of nodes that are currently reserved, might be a better idea. Cool. So the solution is, well, there's multiple ways. There's a couple of ways of doing it. If you're wanting to use just sinfo, you can use the -n-l command that we used before, but then you can specify that you want a given state. So you could run sinfo -n-l, and then state equals, in the example, it says idle. But there's not many nodes that are idle at the moment, so that doesn't give you very much interesting information. So instead, if you go for reserved, I can spell, there we go. Then that gives you a list of all of the nodes that are reserved. And so you know, for instance, that node 1200, 1272, 1352, they're all reserved at the moment. The other way you can do it is the slightly more brute approach, which is to sinfo -n-l and then just grep reserve, and that does exactly the same thing. Although no, it does not do the same thing. That's an important thing to see, which is that if you run the state reserved, it will show you all the nodes that are currently allocated but are currently reserved as well. So they're being used but are part of a reservation. and that's an important distinction. You can always find more information about sinfo or any Slurm command by typing man to get the manual page up. And there it tells you all of the things that you can do. So for instance, -enc, you can also use --" node, etc., etc. There we go. Cool. It's all nice and great to know what other people are running or how much other people are running on the system, but I'm guessing part of the reason that you're here is likely more to be, well, how do you run on the system, or how do we run on the system? And to do that, there's two ways of doing this. There's 2 or 3 ways of running on ARCHER2. We're going to start off by talking about creating submission scripts and running jobs by submitting scripts to the queue, because that's kind of the easiest way to do it, and it's also one of the nicest, most hands-off way of running on ARCHER2, which you can just set up, launch, and step away from the computer, come back the next morning to check whether your thing ran properly. And for that, we're going to talk about the sbatch command. The sbatch command is the sbatch command allows you to submit a Slurm job to the queue, and as part of the sbatch command, you can specify you can write a submission file called let's call it sub.slurm, and within that submission file, you can include a number of lines to tell Slurm what you want to do. So in most cases, you'll want to start with a #bang /bin/bash or whichever shell you're more interested in. I tend to use bash, just to tell, just for Slurm to know this is a shell script. And then you can tell the Slurm sbatch command different commands by using #sbatch. You can also have it in lowercase, that works as well. But you can specify certain things in there. So you can specify, for instance, the partition you want to run on. Like I want to run on, say, standard. You can specify the account that you're running on, which budget this is being paid for under. In this case, it's going to be TA022. You will need to specify certain things, including the 2 that I've mentioned. Some other things you might want is the quality of service. Are you running this on the short queue in order to get it run faster? Are you running this on the standard queue because you need longer time than 20 minutes? That sort of thing. In this case, I'm going to use the short queue, just because ARCHER2 is busy. If you're using the short queue, you're going to need a reservation number. The reservation is short QoS. It's not a number, it's a reservation name. Short QoS. If you don't have that, you're not able to run on the short queue. Other things you'll need if you're running on the short queue is to specify the time, because the short queue will not let you run things that are more than 20 minutes long. You need to specify a time which is less than 20 minutes. In this case, I've done a time which is 0 hours, 2 minutes, and 0 seconds. You may be interested in specifying how many nodes you want to use. I'm going to use 1 in this case. You might want to say how many processors each node has, which is tasks per, how many cores each node has. Tasks per node equals 128 because I want physical cores. You might want to say how many OMP threads you want per task. OMP thread you want per MPI task. Per task, in this case, is going to be 1. And then a couple of other things you might want to do are things which really help the system, things like making sure that Slurm knows that you do not want multi-threading by using the hint no multi-thread command. And the final thing is you might want to help Slurm know how to distribute your jobs across nodes. block. So this last one is a bit complicated, but essentially what this last distribution command does is it's telling Slurm when Slurm launches a job, if you're running it on many nodes, you want Slurm to fill up the jobs first so that they fill up a node entirely before they go onto another node. So let's say I'm running on 3 nodes. The first block command is telling Slurm, I'm running on 3 nodes, but I want you to fill up node 1 before you even start putting anything on node 2, and fill up node 2 entirely before you start putting anything on node 3. And then the second block command is telling Slurm, oh, by the way, each node you already know has 8 NUMA regions. I want you to completely fill up one of those NUMA regions on a given node before you even start considering adding anything to the next NUMA region. And just to make sure that you fill up everything so that parts of the system that are most likely to communicate together will be closer together, which means that your job will hopefully run faster. Just looking here. Now, the next bit of the command is a bit of a cheat. I've already mentioned that if you run a module purge command, you end up with an environment which is very, very hard to work with, and that probably your best bet is to log out of the system and log back into the system. Well, unfortunately, the login nodes do not have, like you start off with a very minimal module system, almost as if you run module purge. So we've made it so that if you have the module load epcc job end command, you'll be able to access all of the modules that we talked about that have been installed by the ARCHER2 support team. So things like Gromacs, things like lamps, like VASP, etc., etc., etc. Which is why this module load often has to be part of your batch script. So far I've mainly been telling Slurm what to do up to the point that I finished saying sbatch. Once I stop saying sbatch, I'm now telling the compute node what to do, rather than the Slurm scheduler. Rather than telling the Slurm scheduler, please do this, please do this, please do this. Once I finish my last sbatch command, everything underneath it is just a normal shell command that I'm wanting to run like I would if I just had a shell executable, essentially a bash script that I was running. So module load epcc job env, and then the final thing is Slurm comes with its own version of MPI executable called srun. So instead of using, say, MPI run or MPI exec or something like that, on ARCHER2 you can run srun, and by default it will use up all of the cores that you've attributed to this. So in this case I've used a single node which has 128 cores, which means if I just run it like this, this will run on 128 cores, and then I can write whatever program or executable I'm going to run. Just to check, I mean, it's probably not going to work, but I don't see why it shouldn't, but it might not. I'm going to srun hello.x, which is the hello world program that I mentioned before, after which I will change my script to look like the one in the other file. Once this is all done, I can submit my job by running sbatch and the name of the submission script. So in this case, sub.slurm. I tend to name my Slurm submission scripts with a .slurm at the end. That's just my personal preference. You could call it whatever you want. You don't have to keep to that convention. I can do that, and then I can check on my job by running sq-u $user, which will show me just my job and where it is. At the moment, it's queuing, which makes sense. As we said, ARCHER2 is quite busy at the moment. I can even follow it a bit more by by just adding the watch command in front of that. And what that command does is every 2 seconds, if you look at that number here, it updates to show me whether my job has changed at all. Again, ARCHER2 is quite busy. This might take a while. And indeed, it's a good way. It gives me a second to mention something else. So why did I bother needing, or why did I need to add the -u $user at the end of the thing? Well, it's because if I were to just run sq, this would list all of the jobs currently queuing on ARCHER2. And it shows all of the jobs and a lot of information's here. You have the job ID for all of the jobs, so like this one. You have which partition they're being queued under, they're all under standard. You have the name of the jobs. You have the user who's running the jobs, their username. You have the state of the jobs, which is either PD for if it's pending, R for if it's running. You've also got, you're not going to see it here, but CG for if the job is about to exit. And then there's a couple of other things you can have. You have here how long the job has been running for. If it's pending, it's not been running for any time at all. But if you go to some of the running ones, say this one's been running for 4.5 hours, a bit more than that, this one for 10 hours, etc., etc. And then finally, you have the number of nodes that have been requested. So this one wants a full system job, this one of 1024, this one wants a 16-node job, this one wants a 30-node job, and then right here it tells you why the job is currently pending if it's not running, or which nodes, the list of the nodes on which the job is currently running. So for instance, you know that this job here, job 169089, is running on the nodes 1224 to 1239. And if you do the maths, you'll notice that that is indeed 16 nodes. Whereas the job here above, 169090, is running on 1038, 1737 through 39, 1787 through 92, and 1836 through 41. So lots and lots of information to be had here. Looking back a bit at the pending jobs, you'll notice they can be pending for various reasons. Most of them are pending for priority. Priority just means your job is not currently at the top of the queue. As jobs finish that were launched, that were submitted before yours, your job will slowly move up and up and up the queue until finally it runs. But you get sometimes some other things. So for instance, this full system job on 1024 nodes is job held admin. That means that the system administrators are holding this job, presumably because there's not currently 1024 nodes that are available to run on right now. Job held user means that the user has not currently or has asked for the job to be held, so it's no longer in the queue or taking up a spot in the queue. There's going to be another couple of things. I'm just looking real quick to see if there's any interesting ones. Dependency never satisfied. I'm not too sure what that one is. There we go. QoS max node per user limit tells you that this user is running more jobs or has asked for more nodes than they are allowed to according to the queuing. So each user can have a maximum of 256 nodes, or can be asking for a 256 nodes worth of resources at any given time. Otherwise, your job will just not queue until your previous jobs have run. What else? There are resources. They've probably asked for things which require more resources than the system has. But as you see, most of them are definitely priorities. Dependency never satisfied is the job is not physically possible. We've done QoS max limit. Yeah, cool. So with that, hopefully, nope, my job is still queuing. So this is taking a bit too long. So I will use the trick that Juan and I had prepared for this. So my job is taking forever to run, and I'm not too happy about that because I want to demonstrate what the job does. What can I do? Well, if my job is taking too long and I realize I don't want it to run, I can run scancel and then the job ID, and that will cancel the job. I run this, and then if I run sq minus u $user, there's no job there. And just to check, there's been no output made from my job. Now, Juan and I expected that this might be a problem, so we have set up a number of for today and tomorrow, we have reservations available. So of the nodes currently reserved that you will have seen, some of those were reserved for this course. So how do you use a reservation? I can show you this as well. Oops, let's not cut that. That's silly. You can find the reservation for today in the course Etherpad. If you're running a reservation that you've made rather than the short queue, you use your reservation number and you queue to standard, like so. Yeah. Now, if I run sbatch sub.job sq -u $user, hey, look at that, it's running straight away because I am running on our reservation, which means there are, I think it's 10 nodes, which are just for this group. To use the reservation, you will need to be a member of the TA 022 budget and be on that account. Okay, cool. So the jobs run, huzzah! And if I were to ls-l rt, the jobs run and seems to have and there seems to have been created an output called slurm, the job number .out. If I look at that output, what does it say? It tells me for all my processors, it says hello from processor and then the processor number, and it doesn't output the what's the word I'm looking for? It doesn't tell you how many processors were run on. The reason for this is because I did not give enough space for processors, the 3 figures necessary for processor numbers to be written. This is a problem with my Fortran code. It's not a problem with how the nodes run. Yeah. So, run well, and I'm actually a bit happy because it's always a bit scary to do something like that. But that's run well. Now, going back to the practical for this session, this session's practical uses a very similar program to my Hello World, though it's similar, but a much more sophisticated version of that. It uses a little program called XT-High, and you want to use version 1.1. And what XT-High does is it will get every single core that's assigned to XT-High. So in this case, all 128 cores from all one node that I'm asking for, to say, I am running this as an MPI task or an OpenMP task, and I am a core or a logical core, and I am on node 1 or node whatever. So if I now run sbatch sub.slurm, my job's running again. I'm not fast enough to do that, but yeah. My job's running again, and if I look now, I've got a new output for my second job, which is my XT-High job. And in my XT-High job, as I said, for every single node and every single processor, it tells me this processor here is on node 0. This is using C. This processor is rank 0, meaning it is the lowest rank processor. It is thread 0, and it corresponds to the physical core 0 on the system. So for instance, I know that rank 116 on the same node corresponds to the physical processor 116, which is not too interesting in and of itself right now, but it's kind of helpful if I were to run with OpenMP threads, which we'll be doing in a sec. So at this point, I have put in the, on the course website, I have put a code which is very similar to the one I just ran. The only things to note are the one on the website uses 2 nodes. You're welcome to keep that the same or change that. And the other big difference that you might be interested in is using the reservation. I strongly suggest using the reservation, and you can use the reservation by adding the line. I'll copy the line into the chat to make it easier. Now, what I'd quite like all of you to do is to, on your ARCHER2 accounts, try to run this same job. I'm going to put the reservation. I apologize for the tunnel. That's how you add the reservation information. But yeah, if you could all try to run this job and write done when you've managed to run this, that would be great, please. One thing to note, which is easy to forget, as Juan mentioned earlier today, the login nodes can see both your home directory and your work directory. However, the compute nodes, the backend nodes, can only see your work directory. Therefore, you will notice I ran all of this from work. You will need to go into your work directory if you want to submit jobs to the compute nodes. Otherwise, it won't run. So you will do something like cd/work/TA022/TA022/ your username, and then wherever you want from there. Please let me know when you have successfully run your jobs. Perfect. Cool. I mean, congratulations to, I'm not sure if this is your first ARCHER2 job or not, but you know, the first one you'll have run this course. So. Great, so I think that a couple of people have managed to finish their jobs. So some things in this code that I did not include are things like -- job name lets you specify the job name you want. Whenever I ran SQ, it just used the name of my submission file. I could have changed that to something else if I'd wanted, if I had put a job name to it. Nodes we've mentioned, tasks per node we've mentioned, CPUs per task we've mentioned, time we've mentioned, all of this we've mentioned. The srun command, I guess, is the big part that I've glossed over and just said this is roughly the same as MPI exec. We'll talk a bit more about that in a second, because actually it's while it does do that, there's also a couple of other functions that it can serve, which are really cool. We've submitted a job. So now that you've run a couple of jobs, I guess my next question for you is, I've put in a lot of information into this submission script. How much of this information do you think is actually absolutely essential? How much of it is required for your job to be able to launch? Or how many of these sbatch commands do you really think you need for your job to be able to run in the queue, or to be able to go in the queue? So if you want, I'm going to give you 10 minutes to have a play around with this and try to answer the questions that are currently there. So do you think that your job would run if you ran without a budget? What about if you didn't specify the tasks per node, the number of nodes, or the wall time? And like, what are the default values, and what is the most minimal script that you can launch? As before, please let me know when you're done by clicking done or typing done. And my pro tip for today is, if you ever want to comment out a part of the sbatch part of the script, the easiest way to do this is to, I don't know, let's say hint no multithread. If you put a space between the hash and the s from sbatch, that is now a comment rather than a command for sbatch. So that's probably the easiest way to quickly see what is and isn't needed is to just do that, and now all of the sbatch commands are commented out. And also it makes it really easy to just bring them back as and when you want. One more thing that could be of interest, or could be interesting, is if you could, I'm going to get rid of that because, so if you write down in the Etherpad what you think the answers are, that would be also quite interesting, just to check that we're getting the same sort of solutions. Please let me know any questions that you have, or if you're stuck at any point, I'm more than happy to help. One question from Dennis is, does the .slurm file itself need to be in the work directory, or just the files used and written in the run? The slurm file also needs to be in the work directory, I believe. I'm pretty sure. I'll check that right now, but I'm pretty sure. Yeah, I mean, no, it definitely does, actually. The reason for that is that by default, Slurm will write in the same directory that it is launched from. And if you launch it from home, it can't write to there because it can't see from the compute. It can't see it from the compute nodes. And just to amplify, just to like prove the point, this submission script is loading a module. The module is available on /work, which means that the executable xt high is in work. But if I do sbatch sub, I get an error saying, oh, I don't get an error. Maybe it does work. Okay, it's skewing forever because priority, cancel. I believe it just fails at the writing stage instead.
Also, I see there is a warning saying that you're submitting from your home directory.
Yeah. So one thing I am interested in finding out is if I do something like that, which means that, so what am I doing at the moment? I'm piping whatever comes out of there into my work directory to see whether this runs. The other thing I'm doing as well is I'm going back onto the reservation so that this will run in a matter of seconds rather than days. Cool, there we go. And if I do ls/work/ /tao22, that file did not happen. So even though the job launches, it doesn't output anything, and the job actually crashes straight away if you try launching from home. Cool. Are there? So I'm noticing that no one's putting any answers in the Etherpad. Is that because you've not reached the answers yet, or because you'd like me to talk you through them now? Would you like more time to do this exercise, or would you like me to give you the solution? And please do let me know in the chat, right? Solutions? Yep, that's one for solutions. Happy to give them. The first step of what is the minimum number, or I'll start with the last one actually, the number 5 extra credits. What's the minimum number of commands? The easiest way of finding that out is just comment everything out. Comment everything out, and then sbatch sub.slurm. What does it tell you? It tells you error, job rejected because job rejected, please specify a partition. Okay, fine. It wants a partition. Let's uncomment the partition. Sbatch sub, and now it's telling you your job has no time specification and the default time is short. You can cancel your job with scancel job ID if you submit, and then it says error, invalid QoS specification. So it's not happy because I didn't give it because it's not happy about the QoS. So okay, fine, let's uncomment the QoS. And if I submit this, it gives me the same warning as before because it's a short thing, and then it says job submitted. And if I do sq-u $user, my job's in the queue. It'll be in the queue for a while because, again, ARCHER2 is busy. But if I were to cheat a tiny bit just to show you, again, proof of principle, and add the reservation just so that it runs faster, it submits. and it's already run. And if I look at Slurm 8424, which is the job ID of the job that I just launched, well, it ran perfectly fine. And it seems to have run on a single thread, on a single node, on a single thread, on a single processor, which actually gives the answer to 2 of the other 4 questions. So the other questions were, how many tasks per node does it use by default? Well, from the looks of this, it's only run 1 task on 1 node. So what's the default number of nodes? It's going to be 1. What's the default number of tasks per node? That's going to be 1. Which budget or account is the job charged to? By default, well, I've only got 1 budget for this, so it makes it kind of easy. It's charged to the TA022 budget, but you can find out that information and the last answer by using the Slurm account. What's it called? The Slurm account command, which will give you lots of information about a specific job. You can use Slurm account -j and then give the job ID. And then you can do, I'm going to use --long to get the full output, and then show you a way of getting a reduced output. And that tells you loads of information, way more information than you could probably or want to know, including what the job ID was, what the job name was, what partition it was run on. I think amongst other things, it'll tell you which account it was run on. I can't quite remember where the account will be. It'll also tell you how long it was run for, how long was awarded to it. But actually, there's a way of cheating, which is you can use the --" format command equals, and then what you want. So what do I want? I probably want, let's see, just reading through these, there's always loads of these. Sorry about this. I'd never know these off the top of my head. I could also just cheat and look, to be honest. I think it's alloc time, if I remember correctly. I might be wrong. Nope, that's not happy. I'll just cheat. You can find that it's time limit. There we go. If you do --" format time limit, it tells you the time limit is 1 hour, which means the default time limit is 1 hour. I guess account. There you go. That also tells you account. So you can find what the time limit is. You can find the account under which it's been run by default. Now, for this, in this very specific case, I had a default account. The reason for this is that I am only associated, or this user account is only associated to 1 budget. In the case where you've got some sub-projects, which again, Juan mentioned a bit earlier today, in the case where you've got sub-budgets, it can quite often be the case that you'll end up running, you will end up having an effective account for each sub-budget, and Slurm will not necessarily know which one is your default account. So it's not always the case that you have a default account. Cool. We've talked about using SQ. We've talked about using scancel. Cool. srun. I mentioned before that srun has some other nice quirks about it. I'm going to module load xt high 1.1. It is possible to launch a job from the login nodes using just srun. And the way that that works is in a very similar way to the sbatch way. You can take all of these commands, so the --" partition equals standard, the --" QoS equals that, the --" reservation equals that, and make from the login node a super long srun, --" partition equals standard, minus minus QoS equals standard, the one I cheated for because I'm not going to remember the reservation, minus minus time equals not 2, 0 to 0, minus minus nodes equals 2, minus minus CPU tasks per node equals 128, minus minus CPUs per task equals 1, and everything else. And then at the end, have your executable. For instance, in this case, it would be xt high. And if I were to run this, this will queue that srun job and then run that srun job and print it out to screen. You'll notice that this bit here has like 513. The reason for this is because I did not put the hint no multi-thread. So xt high in this case is always using the physical core rather than one of the logical cores, but it's telling you this physical core actually has 2 associated numbers from the multi-threading, which is why the output's a bit different, but it's roughly speaking the same as before. Oh no, it's actually just running, it's using every single one. Cool. So it is possible to use srun to launch jobs. Now this is going to be quite cool because this allows you to do interactive jobs quite easily. There is a special command called --pty, which lets you launch a shell. And then you can do /bin/bash. Let's maybe do this for a bit more than 2 minutes for 10 minutes, well, 5. And before I do this, please note that I'm currently my username at user access node 1. When I do this, I am now my username at node 1011. I am on one of the backend nodes, which can be really cool because, for instance, I can now do things that I couldn't before, like, for instance, srun -n to hello.x runs a parallel program in an interactive fashion. This is a way of getting an interactive shell on one of the compute nodes. So yeah, srun, as I mentioned, srun has a really large, what's the word I'm looking for? srun has a very large potential. So underpopulating nodes, sometimes you might want to underpopulate nodes on ARCHER2. The reason for this is while there's 256 gig of memory per node on ARCHER2, there's also 128 cores per node on ARCHER2, which means that you've got an effective 2 gig core. Sometimes if you're memory strapped, it's worth running on less cores in order to have more memory per job that's running. So what this exercise is asking is, how would you go about, in the sbatch option, how would you go about running the following things? So what would you change to run a 4-node job with 64 tasks per node? I'm happy to, well, actually, given the time, I'm probably just going to give you the answer for this one. So let's make this back to how it was before. So 4 nodes, quite simply, you change that to 4. And we said 64 cores per node. Well, instead of 128 tasks per node, we would change that to 64. And that would be 4 nodes, 64 tasks per node. Is that right? Yep. 8 nodes with 2 tasks per node and 1 task per socket. That one's really tricky. The way you do that, there's many ways of doing that. So obviously 8 nodes, 2 tasks per node. Here you would get rid of this distribution because actually you would get rid of this distribution, or you could just do distribution cyclic is one of the ways that you could do this and get rid of the block. The other way you could do this is to comment this out and use a CPU mask. And the way CPU masks work, I never quite remember, but it's essentially minus minus CPU mask, and then you need to specify how it's done. A CPU bind, there you go. So minus minus CPU bind, and then you want a CPU mask, your type of binding, and then you need to specify, there it is, so map CPU. So that would look like minus minus CPU bind equals mask CPU, and you want one on 0 and one on 63. And that should roughly do it. And then the final one, 4 nodes with 64 tasks per node, ensuring an even distribution across all 8 NUMA regions. That one is also quite easy to do, because that one you just change the second of those to cyclic, and then it will position. What cyclic means is if you've got 4 nodes, each node has 8 regions for a total of 32 NUMA regions. What cyclic will do is it'll say, okay, the first job will be attached to processor 0 on NUMA region 1. The second one will go on processor on the first processor in NUMA region 2. The third one will go on processor 1 in NUMA region 3, etc., etc., etc. Is probably the easiest way of doing this. Oh, and you can specify n tasks per socket to make that a bit more easy. And that one is what that one is doing is it's specifying the number of tasks you want per socket, as well as another way of doing this. So for hybrid OpenMP and MPI jobs, the way you do this is by changing the CPUs per task. Actually, I'll do that now because it can be quite fun to do. Let's go for 8. Let's go for 4 because that way I know the numbers. There we go. And then I'm going to export So what have I done? I've said that for each each node has 32 MPI thread, or will have 32 MPI threads running, and each MPI task rather than threads will have 4 OpenMP threads. I've then also defined the number of OpenMP threads as 4, just to be consistent. Tomorrow I'll show you a cheat for actually setting this to the Slurm environment variable that you set CPUs per task as, so that you never have to remember to do it. And then the rest of the code is the same. I will change that back to block. And if I am going to remove all of the slurms first, because there's a lot of outputs already. And if I why is that? 12.8. Ah, that's why. Let's go for 2. There we go. And so if I do that, it's already run. And if I do that, you see that instead of running 256 jobs, i.e. instead of running 128 twice because I'm running 2 nodes, it's only run 64, so 32 twice. And each job has been run a number of nodes, and it tells you the nodes. Each job has been run, each job has been run on a number of cores. It tells you which cores from which node each task has been running on. And as you can see, there's 4 cores per task. So that is how you can define and run hybrid MPI with OpenMP job. So some things to bear in mind is we've talked a lot about the NUMA regions in on ARCHER2, and NUMA stands for non-uniform memory access. There's 4 regions per socket, so 8 per node with 16 cores per region. the best way to think about those is essentially like if you've never heard of them before, the best way to think about them is the cores within a NUMA region will communicate to each other faster than they will to cores in another NUMA region within the same node. So for communication times, it's usually ideal to keep your fast communications within a NUMA region, which does mean that which just means, there's, again, like tomorrow you'll be able to see this in one of the tutorials, one of the practicals. But programs where the threads of a task span across multiple NUMA regions are much likely to be less efficient and significantly less efficient. I've seen an order of, a factor 10 slowdown in at least one occasion because of cores not matching NUMA regions or threads not matching NUMA regions. So it's always worth counting and fitting to make sure that you do consider the layout of an ARCHER2 compute node when you're submitting your jobs. With the numbers that we've said, the following are good runs. So 8 MPI tasks with 16 OpenMP threads per task. That's 1 MPI task per NUMA region. 16 and 8 gives you 2 MPI tasks per NUMA region. 32 and 4 gives you 4 MPI tasks per NUMA region, and 64 and 2 gives you 8 MPI tasks per NUMA region. The standard outputs and errors always go to the slurm.out file. We've already had a look at this. And the final thing, which I will really glance over because I think the srun method is a bit better, it's possible to, there's a command called salloc. And salloc is a command that lets you, much like srun lets you start a shell within the compute nodes. What salloc does is it allows you to reserve a couple of nodes, and then if you ever run anything using srun from the login node, it will always submit to those nodes. They both do similar things. I quite like the environment of being in background and being in the compute nodes. But yeah, I mean, the way it runs is exactly the same as before. If I do srun here and then change that to salloc, oh yeah, it won't be happy with with me running shell. There you go. What happens? Well, the job's launched. It's waiting for resources. As soon as the resources are available, it tells me you'll be running on these 2 nodes. However, I am still in my on the user access node, on the login node. And then from this, I'm able to srun xt high. Should be able to anyways. Yeah, I'm able to srun xt high, even though I'm still on the login node. It will run xt high on nodes 1011 and 1012, the 2 that have been allocated. The other thing I can do as well is if I do sq-u $user, it shows me, hey, look, you've got a job that's taking 2 nodes that you've had up for 42 seconds, which is just my allocation. So that's another way of running interactive jobs, or jobs in a more interactive fashion. I do, as I say, prefer srun because I feel it's a more pure form of interactive jobs, but I'm sure many people will tell me that I'm wrong and give many reasons why that's the case. With salloc, you can either finish it by canceling the job by doing scancel, or you can do exit. I went with the scancel route. And yeah, and that's pretty much, that's already a lot of information about the ARCHER2 Slurm Scheduler. It's one of those things, it is a gift that keeps on giving. It's a lot of effort to get your head around the starting, get your head around it and start using the Slurm Scheduler, but actually it's got so many little hidden functionalities that make life a lot easier. As soon as you start to get used to it, everything starts to make sense. Things are sensibly named, things things almost, yeah, things make sense, I guess is the best thing I can say about it. We've got a fair amount of information about running jobs on ARCHER2, which tells you a lot of other things about Slurm. that I've not covered here. And then Slurm also has a large number of documentation, some of which is better than others, I will admit. It's not always the easiest documentation to read, but there's a lot there. You're able to launch parallel jobs within an SBatch script with srun, or you can also launch them from the log with srun. And there's a number of different, it says partitions here, but frankly it's queues. Queues being quality of service. You define them with the quality of service command, the QoS command. I've not really talked about those, but there's a couple there available. So you've got the standard queue, which we've used because that's how you use the reservation. There's the short queue, which lets you use up to 8 nodes for up to 20 minutes. There's the long queue for 64 nodes for up to 2 days. And then there's the large scale queue for if you're wanting to run something on, I think 90% of the system is where we've got that capped at the moment. You're only able to run it for 3 hours. If you were wanting to run something bigger than that, we're more than happy to facilitate and accommodate it, but you would need to write to us at support@archer2.ac.uk for us to set that up for you. So with that, for the final probably half hour rather than 45 minutes, to be honest, for the final half hour of the session, we have a small practical where the idea of this practical is to get you to run jobs on ARCHER2 and do some performance testing. So by now you should be able to, you should know everything that you need to know to run jobs on ARCHER2, find information from job outputs, etc., etc., etc. So this, and I'll put the link in the course chat in a sec. This lets you run your own program. You'll be using a program called Sharpen, which is an image processing program, which will help you sharpen a fuzzy image to make it go from a rather fuzzy image to a not fuzzy image. And you can run it by, it is a module, but it's in a bit of a weird place. I think it's in training/sharpen. So module load training/sharpen. And then there's a couple of executables with it. I'm actually going to quickly go in a different directory, make there getting a sound. Sharpen feels like a natural for GPUs. Yeah, it would probably be good on GPUs as well. It's a lot harder to code on GPUs than on CPUs. You can actually find, I think, if you module show training sharpen. Did I get it wrong? There it is. It shows you the path. I think we've actually included we've got the .py file. I'm not sure we've actually got, it doesn't seem like we do have the original program, as in like the source for it, which is a bit of a shame. But yeah, so from the Sharpen directory, actually, where was it? From the Sharpen input, ls, you can just copy the fuzzy image to here, and then you can run Sharpen. There is an MPI version is the one that you'll be predominantly running, but there's also a serial version, which I'll just use here to show you what it looks like. And then it runs, and then it tells you the calculation time to do this image. It took about 3.5 seconds, and the overall runtime was 3.6 seconds. And from that, you should be able to, well, you'll be writing a batch script to submit this to the compute nodes and slowly increasing the number of processors that you're using. You can also at any time load the module XLI, which will let you view the fuzzy image eventually. This takes a while. The X server communication between my laptop specifically and ARCHER2 is terrible. But yeah, so there is the fuzzy image. And then you can also look at the sharpened image. Which has more unique colors. That's interesting. The sharpened image, which actually you can tell that that's a tent and that's some person in front of a tent. So yeah, to start off with, run it in serial like I just did on the login node, and then see about running it on the backend nodes. And what would be great is if you're able to run, increase the number of cores and see how the various times change. That's the final bit of the question. Oops, sorry. Right, so with that, we'll leave you to it. And if you want to put your solutions for runtimes, etc., on the Etherpad, that's always really fun. The times, the various times that people get. Otherwise, I'm happy to pop back in about 15-20 minutes to share the answers that I got for it. As always, please do ask if you have any questions. We're more than happy to answer them. And if you know what the solution to this is going to look like, or if you've already done performance testing, or if you're busy, please also feel free to not carry out this entire exercise. Yeah. Oh, there's. So Dennis, you seem to be the only one participating at the moment in this exercise. If you'd like, I can share my solution with you. Yeah, sure. So I'm particularly lazy when it comes to these things. So I actually ended up trying to run it in a single job, which means my script is incredibly messy. Give me 1 second to share my shell. Yep, sorry, so I'm now sharing my shell. I'm not sharing my shell, apologies. There we go.
Yep.
So what I did was I decided to run all of the jobs at the same time for 1 to 64 cores, but there's a quirk on ARCHER2. I can hear some echo. Is that because your mic's on?
Yeah, I'll take.
Yes, yeah, you're. No, you can keep it on. It's fine. There's only 2 of us here.
It'll echo cancel. It'll be all right. Yeah, that's why I put it back on.
Yeah. So I cheated completely on this one. Essentially, I ran all of the jobs at once for 64, 32, 16, 8, 4, 2, and 1 processor, and put them all to separate outputs so that I can then check the outputs. I wasn't able to get the 128 to run. I'm not too sure why. I've not really looked into it just yet. But there's a quirk on ARCHER2, or actually it's a quirk about how Slurm sets job on ARCHER2, which makes this a bit more complicated than it sounds like offhand, which is that if you tell Slurm run a 64 processor job in background with the ampersand, and then run a 32 processor job in background with the ampersand, what Slurm will do is it will go, okay, I will set the 64 cores, the 64 core job on cores 0 to 63. And then when that's set up, I will set the 32 core jobs on cores 0 to 31, which means that you end up with 32 cores that are running 2 programs, which slows down performance incredibly. So the way around this is to use the CPU bind map CPU that I briefly mentioned at the end of the last session, and then bind them to the physical cores. So these huge strings of numbers are essentially me telling Slurm, well, when I say bind 64, what I mean is bind to the first 64 cores. And when I say bind 32, I mean bind to core 65 through to 65 plus 32, or in this case 96, etc., etc., etc. The disadvantage, of course, is that I can easily make a mistake in this, which will screw up all of my results. The advantage, though, is that I'm able to get all of my results in a single run. Does that make sense?
Yes. Yep. So do I correctly understand that the reality is that tasks and threads inside a single NUMA region interfere because they'll be sharing level 3 caches, DRAM and TLBs and things, but between different NUMA regions you might as well be on a different node. They're essentially completely independent. They don't really affect each other's performance.
I think internode communication is still faster than intranode intranode communication is still faster than internode communication.
Yeah, the communication. But there's no contention over things like memory. Once you're in a different NUMA region, stuff that's running locally in one NUMA region isn't contending for any kind of interconnection bandwidth on node, any kind of memory bandwidth with a different NUMA region.
No, well, it's even I mean, simpler than that in the sense that every single core has a set amount of memory associated with it.
Right, but the NUMA region stuff is about being able to use whatever it is, hypertransport, to actually fetch DRAM off the other NUMA region, isn't it? So you can actually share a common address space between NUMA regions, but the performance is down at virtual memory performance.
Yeah, that's right.
Yeah. So you might as well. It's not as bad as paging off disk, but it's at the CPU level. It's that kind of activity. It's retrieving pages from a remote across a remote interconnect.
Yeah, that's right. And it's essentially like you're essentially saving yourself a whole other level and a whole interconnect. Yeah. So. Yeah. Yep.
Okay.
Cool. So in this case, actually, by setting because I'm running. The part of the reason that I started with 64 nodes, 64 core job is actually to make sure that I am using up whole NUMA regions for the earlier larger jobs, and then for the later jobs, well, they're all in the same NUMA region, so communications will go as quick as possible. Hence, I started at 64 rather than starting at 1, which would offset everything by 1 core per NUMA region, which would make the timings way worse.
Yeah.
But well spotted. So I ran that and then got all of the various outputs. I guess the easiest way to do this is to grep the calculation times. And then you can see essentially 2 seconds, 2.8 seconds, 1.4 seconds, so roughly double. And then as you get closer and closer, it actually scales really well up to 64 cores. I hadn't gotten around yet to plotting it. I was going to. I hate running awk in, so if this goes wrong, my apologies. 4, 5, that should be at the right column, and that should be that. I hate running awk live because I always get it wrong. I got it wrong.
Yeah.
That's because I didn't pipe it.
Yes, people did introduce Perl to avoid having to do awk.
To calc time. There we go. And if I just calc time, I should be able to 1, 2. Sorry, I realize this is probably quite boring watching me.
It's fine.
Edit a file. That's in the wrong place. And 64. And now if I module load GNU plot, and then GNU plot, set log scale, plot, did I call it times or calc times? Calc times. Calc times, boom. 1, 2 with LP. There we go, and I'll need to share my change my screen share because you can't really see it at this point. what you get is that the calculation time is, check if that works. There we go, it always takes a few seconds to share. So what you get is that as you increase the number of processors, the calculation time decreases nicely linearly, actually. It's still in the linear region. But part of the reason for this is because I've only so far plotted calculation time. If instead I were to do, I think, I always forget this, time from output, let's do 1. There's overall time, that's what it's called. But if I do overall time as well, and let's do that to overall time, and then new plot, I'll need to actually do that and exit VI overall time. Didn't output, wonder why. Oh, it's runtime, that's why. Here we go, 1, 2, 3, 4, 5, that's still fine. So if I do runtime,
okay,
like that, and then I should be able to see the, what's that?
Yeah, so we're flattening
yes.
out. We're seeing the job startups taking 0.3 of a second.
Yeah, exactly, which means that your performance is actually effectively dropping, even though your processing time is getting better and better and better. Your serial part, the serial part of your job is taking a bigger chunk of your time. Which makes sense, right?
Yeah.
Yeah. But yeah, so that was roughly, well, that was the entirety of the exercise. We'll be looking at some hybrid OpenMP MPI performance at the end of tomorrow's lesson, if you're interested in that sort of thing. And other than
yes,
that, I think
yes.
Yeah.
Okay, that's good.
Yeah,
I think someone else has come back and joined in as well.
Yeah, I saw that somebody else had joined in. But I think with that, I think it's the end of the session, unless there's any more questions that either of you have to ask. If you do, please go right ahead. Otherwise, I guess we're, well, definitely we hope that you've been enjoying the course so far, and we look forward to seeing you again tomorrow.
Yeah, that's good. And yeah, thanks. And I think this is the scheduled end, so you, well, we should let you get away. Well, thanks.
Well, yeah, no worries.
Yeah, thank you so much for attending. And yeah, see you tomorrow at 10 a.m.